All right, so this question is asking us to prove that EFGH is a square. All right, so we have a couple different ways we can do that. We can prove it based on the sides. I know that the sides of the square all have to be congruent and that the corners all have to be 90-degree angles. I could do that to prove that it's a square. Or I could prove that EFGH is a square using its diagonals. I know that the diagonals of a square have to be congruent, perpendicular bisectors. Now, I think it's easier to prove that EFGH is a square using the sides than it is by using the diagonals. So I'm going to do it with the sides. All right, so the first thing that I need to prove is that all the sides are congruent. Sides are congruent. And in order to do that, I need to find the length of each side. Well, to find the length of the side, I need to make little right triangles and use distance formula, or use Pythagorean theorem. All right, so this side is 1, 2, 3, 4, and this side over here is 3. If I do a squared plus b squared equals c squared, I do 4 squared plus 3 squared equals c squared. 4 squared plus 3 squared is 25. And then you take the square root, and the square root of 25 is 5. So that tells me that this side of the square is 5. I could do the same thing on all of these sides. So let me switch colors. Make a little triangle out of it. This side is 4. This side is 3. Hey, when I do 4 squared plus 3 squared equals c squared, it looks exactly like this. And I find out that this side is 5. All right, let's switch colors again. If I do this one down here, this side is 4, this side is 3. Hey, if I do 4 squared plus 3 squared equals c squared, it looks just like this again. So again, I get a 5. All right, switch colors one more time. Check this side over here. This is 4, this is 3. If I do a squared plus b squared equals c squared, I again get 5. All right, so I've now proven that all of the sides are 5. But that doesn't make it a square, because a rhombus could also have all sides that are 5. To prove that this is a square, I need to prove that these corners are 90-degree angles. Well, to prove that the corners are 90-degree angles, I need to check their slopes. All right, so let me back some of these labels out of here. Lots of these labels out of here, sorry. Okay, so now I want to check their slopes. All right, so this side right here, the slope is up 1, 2, 3, 4, and over 1, 2, 3. So EF has a slope of up 4 over 3. All right, let's check the slope of GH, because EF and GH should have the same slope. They should be parallel. I'm going up 1, 2, 3, 4, and over 1, 2, 3. Hey, look, those two are the same. So these two are parallel, EF and GH. All right, so now let's check the other ones. FG has a slope of down 1, 2, 3, and over 1, 2, 3, 4. So it's down 3 over 4. And now let's check EH. EH has a slope of down 1, 2, 3, and over 1, 2, 3, 4. Down 3 over 4. All right, so these two are also parallel to each other. So that's good. That means this is parallel to this, and this is parallel to that. Now we just need to check to see if they are perpendicular. Is 4 over 3 and negative 3 over 4 opposite reciprocals? Yes, they are. This one's positive, this one's negative, this one's right side up, this one's upside down. So because these are all opposite reciprocals, we are proving that these are all 90-degree angles. And because all of our sides are equal, that we proved with a squared plus b squared equals c squared, and all of our corners are 90-degree angles, which we proved with the slopes, we can now say that EFGH is a square.